Okay, so a supernova explodes, then what happens? Well, just like everything else, there must be classification. Type 1, nothing is left. Type 2, there might be part of a star that's left over. Okay, we'll get to type 1 later, but let's look at type 2, supernovas. Collapse of the iron core. Right, and so this is chapter 12. We kind of missed the whole core stuff. But the collapse of an iron core. Neutrons stop further collapse. So basically what's happening is the gravity takes over, and squishes and squishes and squishes and squishes. And then it gets to a point where it's not squishing stuff anymore. It's squishing actual neutrons. You know, like protons, neutrons, electrons. It's squishing actual neutrons, and it can't do it. The power from the neutrons is overtaking gravity, and so it's stuck there. Okay? And then the core rebounds, right? This is when it gets to that neutron part. The core kind of rebounds, a shockwave blows out from the star, and the only thing left is this neutron star. A star or thing that's completely composed of neutrons. Alright, so what does this look like? Well, it's very small. It's about the size of a city or an asteroid. Okay, they like to compare it to the size of Brooklyn. 20 kilometers across. It's probably smaller than Tampa, actually. However, the mass of this thing is insane. The mass is more than the sun. So you've got something larger than the sun, compressed enough so that it's smaller than Tampa. Now, just a little tiny bit of this would have as much mass as a mountain. So as you can imagine, more mass, more gravity, right? So this thing would have a lot of gravity. If you were to stand on the surface, so an average human, 154 pounds, you would feel like you weighed a billion. You would be flattened like a pancake. Basically, until you were just neutrons. Not fun. Neutron stars spin just like everything else, right? However, their spins are fast, super fast. The period, i.e. the amount of time it takes for it to spin, is fractions of a second. The magnetic field, it has one, and it is squeezed together so tight. In fact, this rotation and the magnetic field, the strong magnetic field, is how we can find these neutron stars.
Massive stars generate energy by the nuclear fusion of elements. When these massive main sequence stars reach a certain point, they will have a sudden and rapid core collapse. This collapse is halted by neutron degeneracy. The energy of this expanding shockwave is sufficient to detach the surrounding stellar material, forming a supernova explosion. This is an example of what a Type 2 supernova would look like. After the supernova, all that is left is what is known as a neutron star. These stars are composed almost entirely of neutrons. These neutron stars are extremely hot and are supported against further collapse by quantum degeneracy pressure. Their size is approximately equal to that of Brooklyn,